modeled by description, copy associated drawing. Okay, copy associated drawing. You have to give the link over here. Okay, I would say modeled by and then description. That means whenever you click on to that, suppose if I go with control S, automatically wherever you want it will save with respect to with respect to exactly that means with respect to it will be same. Okay, so in the last class I think we have draft. I think we have to start. Whole is not yet completed. There are some bends like toroidal bend, uh, as well as spinal bend. There are two bends which we'll be dealing. If possible, we'll try to complete spinal, toroidal. Okay, draft as well as one. Once let me check the syllabus. Part setting units, extruding sketches, different types of extrude, above depth option, about extrude cut. These all things we have covered. Revolve has covered, sweep, helical sweep, blend, rotational blend, step. We did not cover I think boundary blend. Okay, leaf boundary blend, and also it did not cover datum planes, axis as well as points. These three four things we did not cover. We will be keeping that for later classes. Okay, these are little bit advanced topics, so we'll be keeping that for that. Okay, and if you come down draft today, we'll complete rounds and auto rounds are completed. Don't worry about auto round. We'll not be using that. Okay, chamfer shell is also completed. Whole we have to complete. Rib we have completed. Mirror tool pattern features we are not yet touched. Okay, and there will be some tools here. Advanced modeling tools, toroidal bend as well as spinal bend. Okay, remaining all are surface. In Creo, basically quilt, QUILT. Quilt means surface. So wherever you find the quilt, it is related to surface. So we have not entered surface yet. So totally we have in part we have spinal bend to complete, toroidal bend to complete. Okay, here modified. These all are surface features, surface based tools. Pattern mirror mirror tool is very copy and pasting is nothing there. Okay, here whole we have to complete. In this draft we have to complete datum points, axis as well as boundary points. The highlighted marks we have to complete part. Then remaining all other comes under surface trim, stick, and all these things comes under These all things comes under surface. Even these all things comes under surface. Okay. Okay, guys. So today, first thing we'll start with draft. Then we'll be going with toroidal bend as well as spinal bend. Okay. Yesterday, I have showed you one example of shisha. Okay. Uh, in that shisha, you have one hinge point. From that hinge point only, you'll be giving like this also, like the same thing you have here. Okay, I'll go with the center rectangle so that I will be center of every plane here. This I'll be giving it to be 500. Is it 50? Yeah. Okay, 500. This one I'll be giving 250. Click on OK. Extrude. I'll come here. Click on mid plane, and the value I'll be giving it is to be 200 and done. Okay. Always work with shaded with edges. Okay. Okay, guys. Understand this. In draft, there are two things. One is the neutral plane, and the other one is okay. The one is a neutral plane. The other, the second entity which you have to select is planes to draft. Okay, or hinge plane, drafted surfaces. Okay, as you see in the system, the hinge point remains constant, whereas this end and this end it will be changing continuously up and down, depending upon the push. It will get up or will be getting uh, will be getting down. Okay, you can see here this hinge point is remaining constant. The same way, uh, whatever you choose as hinge surfaces, it will be constant. And other thing is, always your draft hinge should be always your drafted surface should be perpendicular to the hinge, I would say. Suppose I'll go to draft. Forget about all these things. Directly go to reference. You'll have clear understanding. Here it is basically asking you reference surface, and it is asking for up and in direction and all those things. Don't worry about this. Select over here. It is clearly mentioned drafted surface, draft hinge, pulling direction. Okay. Okay. Always draft hinge and draft surfaces should be perpendicular to each other, or at least I would say should not be parallel. Draft surface and draft hinge both should not be parallel to each other. That means I cannot give this as a draft hinge, and in later I cannot give this as a draft surface. Okay, it will not accept it. It should be perpendicular or at an angle with each other. It should not be parallel. Remember that. Okay. So first I'll go to draft surface. Click here. Hold the control. Click here. Suppose if you're not holding control, click on detail. Click here and add. Like that, you can add or remove some solid surfaces. You can add seed boundary surface. All those things you can do it. Try it out. Okay, I would say just simply select it, hold the control and select what all the surfaces you want to draft. Simply select those surfaces automatically. What are the surfaces you want to draft automatically will be selected. Suppose if you want to remove here, come here, directly click on remove all. Okay. So I want to only draft this particular surface. Okay, click on OK. The next thing I'll be going with is draft hinge. I'll be selecting this particular surface as a draft hinge. That means this surface, the length and the width of the surface and the height of the surface will be constant. It will not be changing at all. Okay, the length and the width will not be changing. Whereas here it will be tilted at an angle. Okay, you can see. Come here and give the angle. Suppose I'll be giving it to be 25. See, in draft, basically there are two things. One is inward draft, the other one is an outward draft. Okay, or positive draft or negative draft. Positive draft will add material, negative draft will remove material. Okay, this one is technically negative draft, which removed material. Okay, so if it add material, suppose I'll change the arrow direction. You can see the arrow direction is upwards. If I change it, it is adding material. So in that way, to come here, click on OK. There is your draft. Okay. I want to talk about the direction here. Okay. There was something called as draft direction. You can see if I go to draft, you can see here pulling direction or draft direction. Basically, in which direction you want to pull it. Mostly, it will be perpendicular to your hinge plane. Okay, if you want to change the direction, you can change the direction. But if the direction is valid, then only it will give you the output. Otherwise, it will not give you the output. So for example, I'll be going with draft surface. This draft hinge, I'll be going with this. Pulling direction, it is already taken the perpendicular to the surface, but I'll be taking at an angle. So I'll come here, I'll be tweaking this edge so that the pulling direction is see. Now you can see how the draft has been changed. Even for 1 degree also, it is giving you this much of result. Previously, our draft was 25, I think. In the last option, we have the draft of 25 degrees. This is a positive draft. See, the pulling direction is perpendicular to the hinge surface here. So what I'll do, I'll come here, select it, select yes. You can see the differentiation, how the pulling direction has been changing. If you rotate it, it will become normal. So like that, you can change your pulling direction and all those things here. Okay. Click on OK and done. See, already this face is drafted. Can you give draft again to that face? We'll try it out. Drafted, reference, select, hinge point again, and we select this side. Okay. I'll be giving 25. I want it to be in reverse direction. If I give more, 50, it will be 8. Okay, that is how draft will be working. Now, what I want to do is I have selected the hinge surface here, right? Instead, what if my hinge surface is this particular plane, which is exactly somewhere in the middle? Okay, what will happen if we select this plane as an hinge surface or hinge? Go to draft, go to reference, drafted surface. I'll be selecting this as my drafted surface, and I'll be selecting hinge as this particular surface. Then again, I'll be going with the value of 25 and rotate. You can see here 2 types of drafts has been added. One is a positive draft, other one is a negative draft. Negative draft in this area, positive draft in this area. That means if you see with respect to this hinge surface, positive draft has material has been added in the bottom. The same amount of material has been removed onto the top. That means simultaneously you have added two, positive draft as well as your negative draft. So if you are selecting this hinge, you are only adding material. You are not removing any material. Okay, you are not removing any material. Okay. Previously it was like this. When you selected, it was like this sometime. Okay. So again, I'll go to reference surface. Select this plane as my sorry. I'll be selecting this face as my draft. I'll be going with hinge. Selecting this as an hinge surface. I'll be going with a value of 25. Okay. If the angle, whatever you see, the same angle will be keeping. Okay. I'll go to split. Here the option is no split. I'll go with split by draft hinge. That means wherever my draft hinge till that end point only it will be giving. Apart from that, it will not give. Actually, we can control here. You can 25. I can double click on it and I can change the value to also 20, 25. Can see how it has been drafted. If you want to change, I think minus 25 would work. Yeah, minus 25 also is working, but I'll be going with 0. Okay. Here in this, you have draft independent. That means with respect to this will be independent. You can give individual values. Dependent means it will be dependent on this. If this is a positive, obviously this will be negative. It will be changing. See, if I give 10, automatically it will change. Okay. Then come here, draft only one side. This will be flag. Draft only the second side. It will go with the other side. Suppose I will give it 25 here. Can see. Change the value, it will add positive. If I change the value, it will add negative. Okay. Split by split object means instead of any other object you want to take that as a reference, you can go with this option. We will not be using that much. Either we will go with no split or split by draft hinge. So that's it about your draft. Okay, very easy option and very useful option as well. Variable pulling direction draft. I have changed my pulling direction, right? Like that you can give 2 to 3 pulling directions, but that also I will not be using at all. We'll never use this. Okay. So hole. The next option will be going with hole. Click on hole. Hole has lot of options here. Okay. First and foremost thing, whenever you go for a hole, whether you want a simple hole like with your dimensions or whether you want a standard hole. If you want to go to standard hole, click on standard hole. The options will be changing. If you want a simple hole, like a regular, not of the standard. Suppose uh, M M16 is the standard thread, technically thread. I'm talking about the thread M16. Okay, the metric 16 thread. Okay. For that M16 or M15 point something will be the hole. Okay, if you don't want that, I want M16.25, 16.2, 16.23 as one hole. That is not standard hole. So at that time, when the hole is not standard, you can simply come here, click onto this simple hole, and you can create your hole. If the holes are standard with particular to UNC or ISO or U these standards, you can actually UNF standard or UNC. These are basically the standards. So you have to know, if you want to keep the standard hole, you have to know the standards. ISO standard, what type of hole you want, okay, what type of hole you want, and all those things you should know. Then only you'll be able to keep the hole. Okay, first I'll be going with simple hole. After selecting whether you want a simple hole or a standard hole, the next most important thing here is placement. How can you place it? Simply click on hole and select the surface you want to place the hole on. Okay. If you see clearly, there are two green dots visible. Basically, these two green dots are for dimensions. Okay. Technically offset reference. Okay. Before that, I would like to give some draft so that I can use that for orientation. Draft, reference, draft surface, draft hinge, 25. I want the positive draft. Done. Next, coming to the hole. The first one is a simple hole. Click on simple hole, go to the placement. Oops. Select it properly. Okay. Select the surface properly which you want to place. Once you have selected, there are two things. Okay. In generally, in every other software, you need to go to sketch, fix this center point in the sketch according to whatever, wherever you want to paste it. I mean, like wherever you make the hole, you have to go to the sketch, fix a point, and come back. But Creo does not allow you to go inside the sketch. It will, okay, it will say, bro, I'm giving only 2 points. With those 2 points only, you have to place your sketch. Okay, that means what I'll do here, I'll take this as a reference and I'll pull and I'll keep onto this edge. That means from this edge, references, it is taking the reference. I'll click here, I'll make it as 125, enter. Okay. Again, this green I'll take, I'll paste it here. Okay. And I want that particular, where is this dimension? It is right there. I want that particular dimension to be vertical. Done. Okay. Or else you can easily change it over here. If you want to change the whole dimension, come here, I'll change the whole dimension. If you want to change the whole height, I want through or up to next, whatever the whole it is there, you can simply keep it. I would change the whole to 100 so that it is visible. You can see. Come to shape, you can even like side to none. You can change the diameter over here. You can change the value side. You go to blind. In blind, I'll be going with 150, 150. You can see the hole which is not blind here. All those things. The shape you can change in this. Now simply click on OK and it is, your hole is done. Once again, we'll be seeing hole option. So first you need to select, okay, I want a simple hole or I want the standard hole. If you want to go with standard hole, you should always have the standard measurements like M6, M14, ISO standards. Here only few standards are available because it is an older version, I hope, or I think you need to buy from the Creo library or something. I don't know how exactly it goes. But in CATIA, you need to buy a library, standard libraries. Then only you will be getting that. Otherwise, they'll give some standard options. If within that standards only you have to use. Otherwise, you need to create your own library and you have to save it. Like that, mostly companies, the standard parts, what they'll do is either they'll buy it, the library, they'll buy it the standard parts, M16 nuts, M16 bolts, those kind of standard library they'll buy it because they'll not have much time to create those things very precisely. They have to create those, so they'll buy it from the vendor itself. I mean, like from the TTC only, most of the times they'll buy it, or otherwise they'll have separate vendors for it. Or some people, what they'll do is, like big companies, they'll have a standard team. standard part team. Okay, they'll have one team for CAD, they'll have one team for TLM. Okay, they'll have one team for standard parts. Whatever the standard parts is required for that project, they'll be creating the standard part and they'll be saving it in a library. Not in this library, they'll have separate library. From the library, you have to pull those parts. Like that, they'll few companies will do. Small companies, there is no other way. You have to create it. All the standard parts. You itself have to create that part. Okay. So whether you want to select, whether you want to go with whether you want to go with the standard part or whether you want to go with simple hole, you need to select that first. I'll be going with simple hole. The next very important thing is the placement. From here, where you want to place your hole, exactly click onto that. Okay, placement. If you want to flip, you can flip it. All those things. Now, the next important thing here is once you have selected the surface, you have to go with referral. Referral in the sense placement. So I'll be taking this as well as I'll be taking this particular surface. See, I'm selecting the surface instead of selecting edges. Why? Because suppose this edge is gone, then this fillet will like this particular whole option will be a default will be an error. Why? Because you have selected that and the next time the edge is not there. If something happened and the edge is gone, it will. So if you select the surface, even 0.02 mm of the surface is also remaining, it will take that value from that. So it is always preferable to take surfaces here. You can see sides, total sides, rather than edges. Until or unless you don't have any other option, go for edges. If you have, definitely don't go for edges. Go for sides or spaces. That would be very good. Okay. So I can double click onto this. I'll be going with 150 150. Again, this one I'll be going with 250 250. No, no, it's gonna type. 250 250. Okay. Okay. Then simply click on OK and it is done. And you have something called your whole orientation. Click on whole orientation. I don't want the straight hole. Instead, I want a slant hole. I have to give some uh, inclination for that. Okay, inclination in the sense reference, not inclination, reference. I have to give some reference for that. Then only I'll be able to see. Right now, my whole direction has been changed. I'll change the value of whole so that you can change 250 250. 350 350. You see, the whole direction has been changed. Literally, I can even give this. You can see. There is no need for me to go make a sketch here. All these things. Simply, I'll make hole and I'll change the direction automatically. It will be giving it. Okay. Uh, this is fine. What if the base which you are giving, which you are putting the hole is a circle or what we call a solid that doesn't have sides? I told you, right? With this arrow and this arrow, we can pick sides and we can give the measurement. What if my base itself is in circular shape? Okay. Uh, yes, you're understanding it, right? Otherwise, I'm simply going on speaking. If you are having any doubt, okay, please let me know. Why it is not hiding. Okay, this is the one. I'll go to sketch again. Select the sketch. Go to the circle. Click on the circle. 500. Click on OK. Extrude. 150 150. Click on done. Okay, done. Exercise. Select this. Go to sketch. Go with the sketch. Oh, no, 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 no. Actually, I want to put the hole, right. My old habit. For symbol hole, I'll not go for hole option. I'll just go for extrude. That's a bad practice actually. You should not follow it. When it is a hole, you have to hole. You have to give a hole option. That is why it has given the hole option, right? In KTA, I would my reasoning will be different. But as far as Creo is there, if you want to put hole, just simply go with hole option. Okay, I'll go to hole. Now, if I select this face, I want to put hole where I will give my references. I cannot take this. You can see. I'll put the and it is not at all taking the surface. You can see it is not at all taking the surface of from where I can give the reference. Can anyone say? Guys, are you there?
Yes, sir. You can.
Adil, from where you will give the reference? Guys, it is less than 1 minute. Can you log in once again with the same link? I'll stop here. Please log in once again.